Hello, so now we're here to talk about transistors. When it comes to transistors, there's really two types of transistors that we talk about. We have the first one here, and I've sort of created the diagram for it. This is a bipolar transistor. I think I'm going to write the next one. And then this one we have it's called a field effect transistor. Again, I'll be providing you. I'm not really an electrical engineering student. In fact, I'm not an electrical engineering student. Let's just make that clear. So I don't really feel too comfortable talking too much in depth about the science of these transistors. I do understand, I have done plenty of research to understand, like, the depletion layer, different types of semiconductors that are used, the doping that takes place, N-type, the difference between N-type and P-type. When we look at the bipolar, the base collector emitter, and then we have the source gate drain model, and how the N-type and the P-type function for the field effect transistor. But I just never had that knowledge validated by a professor or validated against somebody that definitely knows the material or knows the field really well. So I don't feel comfortable talking about it because I might have some misconceptions and I don't want to have to pass those misconceptions on to you guys. So instead I will give you guys a whole body of resources where you guys can study about transistors. I'll link you guys to hyperlink if maybe you guys need to brush up on your circuit physics. Really understanding what in series, what parallel, and what being in parallel means is really going to be important. And again, lots of the resources that I consulted to understand, the difference between like a JFET and a MOSFET, a junction field effect transistor, and I remember it's like the MOSFET's like something metal, something semiconductor field effect transistor, something like that. Again, I'll be providing you guys resources for you guys to go through. But again, because I'm a computer scientist and I like to make things really simple, contrary to the belief of others, I'm just going to say that transistors are effectively switches. Specifically, when we look at the MOSFET N-type transistor, it really does function, which is really the transistor we're going to be using. I'll just write it down. So you guys can do some Googling. The way it functions is current will not flow through given some amount of current applied to the source, it will not flow through to the drain unless power is applied to the gate. So once we have power applied to the gate, then current can flow through easily. Otherwise, no flow, right? And so we can imagine it's sort of like a switch, as I've shown here. And let's just imagine, you'll have to take my word for it. Hopefully you guys know something about circuit diagrams, but this is symbolic notation for an LED. But if we have this LED source right here, we imagine, and we have our switch open, whoa, we have a disjointed, not connected circuit. So power does not go to the LED. Therefore, again, assume that. Assume this is a basic circuit diagram, please. I don't want to, technically there could be some other wiring and whatever, but we're just gonna ignore that, right? So just please assume that these are simple diagrams. And so, again, our LED would be off because no power is reaching it. And so we can represent this with a 0 or an off state. But when we close the switch, we have we can assume that we've created a closed loop. And so our LED will be on, as bright as the sun possibly. And this can represent, and we can represent the LED being on with a 1 or true, right? And again, it functions just like the MOSFET N-channel transistor. It's kind of weird to say MOSFET transistor because the T stands for transistor. Whatever. It functions just like our MOSFET up here, our N-flavored MOSFET. Because if we apply power to the gate, we have, we can imagine we have an LED right here, right? If we apply power to our gate, our switch being closed perhaps, our LED turns on. If there is no power applied to the gate, then our LED is off. That's really the best way to think about transistors. They're literally just switches. Only this specific type. I mean, again, the bipolar transistor should not be looked at in this light. I believe it's called I think it's like it's a transforming resistor. I believe is what the bipolar is like. Given some input, the resistance of this thing changes. again, please do the please guys consult the resources. I'll be providing you guys. One other thing, there's just a lot to talk about this video. I'm so sorry. There's this circuit simulator, which is really cool. We'll be using this. I just think it's really fun. I get to make diagrams and I get to help illustrate some of the concepts that I'm talking about. So I think I'll give you guys a download for it. You know, if you have the hotkeys down. So here's a diagram that I was discussing. You know, we have our LED on and off. You guys can export your, these diagrams, and I'll be exporting all my diagrams to my GitHub account, which you guys, and again, resources down below in the description. But you guys can then import all of my diagrams, and so you guys can play with some of the circuit diagrams I'll be drawing as I show how we can implement the logic gates using transistors, mostly the N type. I think once or twice I had to use a P type, but hopefully you guys will have fun. I think that's all. Again, please use this circuit simulator. Brush up on transistors using all the resources I'll be giving you, and have fun and keep learning, guys.